so once again, good afternoon. I have now the pleasure, after my colleague Katharina Dunst talked about the intrinsic topic of vLamax, and as we heard in the conference so far today, many different aspects have already been discussed, and we are already building a consensus, as Michael has already pointed out. So now I have the pleasure to be able to talk about a bit maybe a more exotic topic regarding vLamax, but still it is very important, and it's still highly related to what we heard before, but in terms of a different sport, not swimming, not cycling, but running. Well, and to start off, I would like to paint a small picture. Well, we all love science, otherwise we wouldn't be here. But actually, the relationship between lactate testing on the one hand and the so-called advanced footwear technology testing is a bit different, a bit challenging, and actually it's a typical example of an unrequited love. What I mean by this and what we can do to solve this problem, I'm going to talk about in the next couple of minutes. So first of all, of course, we have to discuss what is meant by advanced footwear technology. So I am by education a biomechanist, so not an exercise physiologist, but a biomechanist. And as such, of course, we have to go into some detail about what we are actually trying to measure when being worn by the athletes. And what we measure actually is a change of the cost of transport, the energy cost of transport in running, as adjusted, as changed by the footwear, by the shoes that are worn by the athletes. So you all know, since about 2017, 2018, there's been that huge wave of carbon plate running shoes entering the market, and nowadays in every race, not only elite races, but every amateur runners race, you can find plenty of those carbon plate running shoes. And actually, advanced footwear technology is just another term, an umbrella term for those carbon plate running shoes, because it's not only the carbon plate that improves the running economy, that reduces the cost of transport in running, but also the cushioning, so a special foam that is used for cushioning in the midsole, shown here on the right side. Maybe I try to make my pointer, laser pointer, yes, here you can see it. So the carbon plate, the carbon fiber plate is one aspect, and the special cushioning, the cushioning of the midsole foam is the other aspect, and both are important actually. And that's why in the footwear technology niche of biomechanics, the term advanced footwear technology has been introduced to cover both aspects. So again, when we want to talk about the effect of something, we first have to understand what is changed by something, and what is changed by those carbon fiber plates in the shoes. And the cushioning foam is, on the one hand, the longitudinal stiffness of the midsole of the shoe, and by that the running efficiency. It's an improvement of about 4% at the highest value that we can measure. So 4% might not seem that much after all, but if you translate it to a difference in time per 1 kilometer run in a race, for example, in a marathon, then you see that 4% is 4.5 seconds per kilometer at the world record marathon pace, which we are obviously not capable of running ourselves. But maybe if we go for 3 hours or 4 hours 30, then the amount of time saved per kilometer by wearing those running shoes, advanced footwear technology running shoes, increases to even 18 seconds, which is quite much, of course. So this is one effect of the carbon plate, the higher stiffness, and the other, the foam itself, which works in principle as some kind of energy recoil functionality. So on the one hand, we have the carbon plate that stiffens the foot, so the energy loss is reduced, and we have longer levers for the plantar flexors, for the Achilles tendon, especially and the muscles that are connected to it. And secondly, as I already mentioned twice before, the special cushioning foam is very effective in energy saving, so in recycling, literally in recycling every stride the energy that would otherwise be dissipated, at least to some extent. All right, you can see that this effect is really measurable and visible by eye. The first shoe was a carbon plate shoe, and the second one is a normal traditional shoe. You see that the stiffness of the first one was much bigger, hence the energy saving was much bigger. And you can imagine if you do like every step you take, every stride, you will save a lot of energy. And this is actually what we can measure to find out how well or how badly specific shoes work. So what do we measure? Usually in the field of running, lactate diagnostics is not that popular yet, especially in the lab. So outside, maybe on the track and field track and in cross-country tracks, for example, the courses there, you, especially in Germany, find occasionally lactate testing, but in the lab, up to now, the gold standard, if you will, is the spirometry, which is of course understandable because the lactate diagnostics has several disadvantages. On a treadmill, for example, you have to stop it usually, especially at higher speeds, to get the blood sample from your earlobe and so on. But still, we know, especially after our great conference today, that of course the formation of lactate and the accumulation level of lactate is a very important contribution to the total energy metabolism and to the, therefore, to the total cost of transport, the energy cost of running that we encounter in running. However, up to now, the standard procedure is that the energy expenditure is measured via gas exchange rates, oxygen uptake and carbon dioxide output. And you can read this recent publication of my team if you want to. But anyway, I'm going to show, based on this example, what a typical testing procedure for those advanced footwear technology shoes looks like. So first, usually we have a first session in the lab where we run in, or where we have the subjects run step protocol until volitional exhaustion, which is clear. So starting at a very low running speed and then until the test is aborted due to exhaustion. And usually we do this, and it was done in this study as well, with different pairs of shoes. So here we tested 4 different carbon type running shoes. And importantly, we tested them not at just one running speed, but at 3 different individual running speeds, which are located, if you look at the load and the training zone diagram in the end, so load and blood lactate concentration or oxygen uptake, whatever you want to put there. We measured speeds close but still below the first ventilatory threshold. Then we measured directly in the middle, so between the first and the second ventilatory threshold, and directly on the second one. And of course, I don't have to mention that the lactate thresholds should be quite there as well. Why do we do this? Because we know that running speed highly influences the effectiveness of carbon plate running shoes. There are many explanations, technical explanations, which I do not want to go into detail with right now, but we take it as granted that there is this effect of running speed, and therefore it's important to cover the different running speeds that are usually chosen by the athletes in training, in competition, and maybe in high intensity interval training, for example. So these shows those. So 90% of the speed at the first ventilatory threshold, directly the arithmetic average of both, and then at the second ventilatory threshold. And then we did those measurements for every shoe with every subject at each of those three speeds. And what we get out in such a scenario is that we first, here you see the different shoe types, we first get overall energy cost of transport, so in terms of kilocalories over kilogram and kilometer run, for example. You could also, of course, consider it into joules per kilogram and kilometer and so on. I mean, the average values are not that surprising. So you see with the non-carbon plate shoe, you have a small but still measurable higher amount of energy expenditure compared to the other ones. So after all, the carbon plate running shoes, they help to reduce the energy cost of running, which is not surprising and not new, of course. But now please keep this value in mind. In this study, for example, we measured that the maximum increase was around 3% in efficiency. That means around 3% of the energy was saved when wearing a shoe, especially kind of shoe in this type. In this kind, it was the Hoka, but it doesn't matter right now, because more importantly, if you look at those tiny dots here, red are the women, blue the males, you see that there are high inter-individual differences. So for some, for example, one shoe, we can see this better in this diagram. In one case, for example, some athletes got a huge improvement of running efficiency, so a reduction in energy cost of running, whereas others even had deteriorating effects. So they had a higher energy expenditure when wearing this carbon plate running shoe. And you see, it's not easy to tell, so it was not just an outlier. So there are many actually athletes who benefited from them and many who did not benefit from them. Instead, they even got worse results. And the range is around -5 to +10%. So the best might save up to 10% of the energy per stride, and the poor ones, they even need to put around 5% more energy, more effort into the running gait to get the same speed out of it. So why am I telling you this? Because we want to keep in mind that the range in which we are discussing improvements by those AFT shoes is at maximum maybe 10%. Usually it's only 3%, 4% maybe, on average especially. This is very important because we will see right now in the next few slides that the contribution of the lactic metabolism is even above those 2, 3, 4% at the speeds run here in usual testing, so below the first ventilatory threshold, between the first and the second, and at the ventilatory threshold 2. So to make it clear, yeah, by the way, just for shoe types, but many shoe sizes. So if you want to have a look behind the scenes, you are invited to follow the QR code as well. But so again, why is it so important that we should include lactate accumulation? Because if we take out such a diagram, so you are all familiar with this, of course, I suppose. So what is shown here, basically it's the time on the x-axis and the gas exchange in oxygen uptake and carbon dioxide output on the y-axis. The blue curve is the oxygen uptake, the red curve is the carbon dioxide output. And you see, if we start at the low speed, the speed is depicted here with this green stepwise manner. If at the low speed, we have a respiratory exchange rate below 1, which is of course expected. And at the highest speed, then at the volitional exhaustion, we have an RER far beyond 1.0, so 1.1, 1.2 maybe. And additionally, you can see with the orange bullet points here, with the orange spheres, that there is a considerable amount of lactate accumulation during the process, which is of course not surprising because the first ventilatory threshold is passed already around 30 minutes after starting, and the second is reached maybe 25 minutes in this case here. So is it really wise only to consider the gas exchange rates when we know that the formation and the accumulation of lactate is considerable, as shown here in this example? And of course, we know the answer. It is not wise, because if we do the simple calculations based on the formulae that you all are familiar with probably, we see that already at an increase of 2 millimoles per liter in lactate level, in blood lactate level, we have a contribution of the lactic anaerobic pathway of about 10 to 13%, depending on the current oxygen uptake, which is, of course, as I said, more than the effect that we want to measure based on the carbon plate running shoes. So if we do not consider the effect of lactate formation and accumulation, we make a huge mistake in terms of the target variable that we want to look at. So again, this is maybe not surprising in terms of the numbers themselves, but it is surprising that although all this is known, again, here we have shown for different running speeds. It was a different study, but the principle is identical. For different running speeds, we have shown, for example, here with the red symbols, the aerobic fraction of energy cost of running as a function of running speed. And you see the fraction of aerobic contributions reduces to 80%. So 20% at maximum maybe are in the lactic anaerobic pathway. So once we know this, and of course we heard especially this morning with Professor Wackerhage about the background, especially in Germany, of huge history, if you will, of lactate diagnostics and understanding of anaerobic metabolism. So we can assume, of course, that it should be incorporated in current studies. But if you look in all the major studies here, for example, it's Plackett all 2022, although they even write down that they measure at intensities that produce lactate accumulations of like 3 millimoles per liter. Others go even to 4, so until to the second ventilatory threshold, the second lactate threshold. And they do not account for the lactic anaerobic pathway in their calculations. And it's just the general case, I must say. So again, here a study by Schubert, a very outstanding researcher, actually. I really admire him, but even in his recent paper, 2023, they write down that, okay, we stay below 4 millimoles per liter, but already 3.5 would be maybe even 2 millimoles per liter more than the basal value that we measure at rest before the treadmill experiment. So again, they do not account for it. And I can give more examples here. So I do not want to bore you with those details, but you can pick out almost any study and they do not account for lactate accumulation when assessing the effect of carbon plate running shoes or advanced footwear technology in general. And actually, our own work is not an exception from this rule. So we also did not account for it because we were advised not to do so. It was said in the literature that it's not required, but after we had the measurements, we checked it and we found out, okay, those 10-15% maybe even, they are much too high just to ignore them. And so, of course, from now on, we are going to include this. So, and that's already maybe my biggest take-home message for those who are involved in assessing running gear, in assessing running economy in general. Please do not forget is a bit maybe a bad wording, do not ignore your knowledge about the lactate formation, because the validity of most AFT, advanced footwear technology studies, is compromised by the lack of consideration of the knowledge that we have about lactate formation. So it's really easy. I mean, once you have the spirometry in your lab and the treadmill, it's really easy to include just collecting some small blood samples every step and to measure them with some kind of mobile device or centrifuge, whatever. There are almost only advantages, almost. So, of course, the validity is increased, highly increased. After all, it's not expensive compared to the other things. So even the footwear costs much more than maybe 20 lactate sample testing procedures. But of course, there's one disadvantage why lactate diagnostics is not that popular with treadmill diagnostics, with treadmill testing in the lab, because usually you have to stop the treadmill, which of course introduces some kind of error, some kind of bias, because in this short period of time, maybe 20-30 seconds for skilled lab personnel, there's a change in the RER, there's a change in the ratio of oxygen uptake and carbon dioxide output, which of course has another, let's say, biasing effect. But in the end, if we want to interpret changes in running economy amounting to 1, 2, maybe 3%, we have to be fair enough that it is important to account for the changes in energy metabolism accounting to up to 10-15% because of anaerobic lactic metabolism. So in the end, I hope I could convince you that it's definitely worth it, although it's maybe a bit disadvantages at some point, but in the end, the pros definitely outweigh the cons. And actually, there's no other way. If you want to do valid research in the future, we have to do it. So in the end, it is easy to turn this unlucky love story to a lucky one. So we have the running gear, we have the simple mechanisms of testing and collecting lactate accumulation. And so it's easy to make it better. And I hope that future studies will account for it. So I'm at the end of my talk now. Of course, it's not myself who did all the work, but my PhD students and my students. And because I still have 1 minute left, I think just a short invitation. So if you ever come to Magdeburg in Germany, please do not hesitate to contact us. We have our lab there. So we are really happy to welcome you maybe someday and to establish further connections or network that we are building up today with the conference and of course further occasions. And with that, I only want to add that you are highly welcome to follow us on Instagram as well with updates on our research. And I thank Michael and Sarah for the organization of this great conference and you for your kind attention. Thank you very much.
Excellent. Thank you very much for that. That was really, really insightful. It's nice to see a slightly different angle to how obviously lactate kinetics can actually be really, really useful in fields outside of the exercise physiology. I've got a few different questions coming in. First thing, from a running background myself, just a little point is that's a runner's dream that wardrobe, isn't it, with all those carbon plates. So yeah, I'd love to see that in real life as well. So going on to the actual questions then. So do you believe that the reduction in obviously the overall energy metabolism comes from glycolytic, or do we think it's more oxidative? And do you think there's a change, kind of draws into the next question as well, but do you think there's a change, the difference between lower than LT2 and above LT2? Do you think that difference is reflected there? Sorry, I think you've muted yourself.
Thank you. Yeah, very good point. Thank you for raising this question. So actually, it is not easy to answer with a general answer. So if we look, for example, at the general trend that the improvement of running economy is higher at speeds at VT2, LT2, suggests that the glycolytic, so the anaerobic contribution might play an important role there. But we also have the effect of reduction of running energy expenditure, so cost of transport in running at speed far, or at least clearly below the first ventilatory threshold. So definitely we have a contribution of the oxidative, so of the aerobic pathways, and we have a contribution of the anaerobic pathways. But because the effect of reduction of energy cost of transport is higher at higher speeds, there might be hypothesized that the role of the glycolytic pathway is even more important than the oxidative. But I must make a small remark on this. It's not only the physiology, the exercise physiology, which comes into play here at higher speeds, but also the biomechanics of the muscle contraction speeds and the rate of energy recoiling in the Achilles tendon and the carbon plate of the shoe. So it's a very complex general situation, which is not easily, I think, analyzed in terms of different factors. But definitely, I would say that both the oxidative and the glycolytic pathways have their contributions, and I assume, based on the data that we have, that the glycolytic, the anaerobic, are even more important than the oxidative.
Excellent, really interesting, really interesting. So I kind of think that answers Jamie's. So in the Q&A bit, there's Jamie, but have you investigated the changes in lactate kinetics above LT2 or max lactate steady state when and when not wearing the carbon foot AFT? Are there any differences here? Typically, studies look at the effects on AFT on respiratory thresholds below LT2. Less is known on the effect of AFT on metabolism above. So yes. Do you think that's something going forward that you'd look to introduce more into the field? Yes, definitely. So this is one of our next research objectives that we are going to pursue. Actually, it is very sensible to work to test at VT2 at LT2, because this is usually the speed that the 10K races, for example, are one in which the effect of the carbon plate running shoes of AFT in general might be greatest. So it's not such a good idea, in my point of view, at least, to test always below LT2, because it's not the training zone in which the real competitions are won by trained athletes. So we should definitely go to VT2 and even beyond, especially with respect for, we talked about triathlon this morning, so sprints between, so it's not always just a constant effort over a distance. You have to be tactical, you have to maybe catch your group, or maybe you have to try to escape your group, and that's why also speeds beyond the VT2 speed are important, but they have not been tested yet, at least not in a systematic way, and we are going to do this in near future. But as you can imagine, we do not always have such a wardrobe full of shoes, and so we were given them only for
limited period of time, and so the next challenge will be to get another sample of different shoes of different manufacturers for testing over a sufficiently period of time, sufficiently long period of time. But that's our objective, and as soon as we get new insights into that, I'm happy to share them with you.
Excellent. Well, thank you very much.